Okay there, hey Gord. So, I think I have Lab 9 figured out here. I think I'll go through it with you and try to explain some of what's going on. I'm just going to build it from scratch and we'll look at it. I pulled up from Google here just a picture of the pinout for that 555 timer. I think it'll help us out in figuring out what all those pins mean. I was kind of lost with that for a little bit until I found that there, that photo showing you what it's all about. So looking at the lab on page 46 there, pretty easy to start out here. I think we can start out with two resistors. So we'll go and say add a resistor, and I'll draw two of them in just to get ourselves started. The first one's a 1K ohm, so that's already set. The next one's a 10K ohm. Oops, so we'll go and I'll change that. Edit. Make that a 10K ohm. And those two there are connected, so I'm going to connect those with a wire. And after that we got a capacitor. So it's a passive component, add a capacitor. We'll bring that there down like that. And he has that listed as a 0.1, what is that, nanofarad? So we'll change that to 0.1 nanofarads, or whatever that means. Pretty small guy. So carrying off the top here, so off the 1K ohm resistor, looks like he has a cable going out this way. And that tees off to our 5-volt power supply, so input sources, a voltage source, one terminal. We'll bring that up there, 5 volts. Nice, good to go. Then on the bottom here, after the capacitor, it comes down right to ground. So let's take that and I'll pull it across. If I can, just add a ground in there. It's kind of hidden by the scope, but that's okay. The next big thing there, of course, is the timer itself. So I gotta find that here someplace. I forget where it is. No idea where it is. Active building components, maybe? Digital chips? What the heck? Where did I find this thing? No, I can't find it. Oh, there it is there. Add 555 timer. So we'll draw one of those guys there in. And this is where that drawing kind of comes in handy. So he says off of the ground it goes over to pin number 1. Looking at the drawing, pin 1 is the ground. So right away then I can say off the ground, which makes sense. I'll just tie that over to this guy here, if I can, if it's possible. Oh well, we'll just do this. Same thing, so that's tied to ground now. That's that part done. He also has in the drawing pin 2 and pin 6 tied together. So looking at our drawing there, pin 2 is timer and pin 6 is threshold. Luckily for us, they're side by side on this, so I'll just do a small little wire like that. He also has pin number 7 going between the 10K and 1K ohm resistor. Pin 7 here is our discharge. So that's this guy right here. You can bring that guy over and put it somewhere between these two resistors. Easier said than done there. Going around the top here, he has pin 8 going to the 5-volt supply. Looking at pin 8 here, pin 8 is the VCC, so that makes sense. That's our power. So we can tie off of the 5-volt supply and go into the V-in. Pin 4 goes to the exact same line. Pin 4 on this here is the reset. So we can go to the reset. And it's going to go, oops, that wasn't very good. Let's delete that one. Bring it up. We'll bring it over. Bring it across. Out of pin 5, we're going to a potentiometer. Pin 5 on this here drawing is our control. Right? Yeah, that's our control. So you can bring our control, which is all the way down at the bottom here. So where it gets kind of messy, you gotta kind of cross over these two. It still works the same though. And then we'll add a potentiometer in there, if I can. Where the heck is it? There it is. Potentiometer, and it goes to the center of the pot. So we'll just drag that right out. Oh, it didn't work well at all. Let's delete that. That was no good. Let's try this way. Yeah, that'll work. And that there's a 1k ohm pot, so we can check that. I'm pretty sure that's what that is. Yeah, 1k ohm. So out of one side of the pot, we attach up to this cable right here. Like that. And out of the other end of the pot, we go to a 220 ohm resistor. So we'll draw that guy in. And then we go to ground from there. So far so good, I think. Last thing left is our output, which is now off of pin number 3. So out of pin 3 he has our output. That's our output right there, so we can add a wire. We'll just come all the way over here, get out of the way. The first thing he does is go into a 2.2k ohm resistor, so we'll add that in. Edit that. 2.2k ohm resistor. Into that he goes into an NPN transistor. So we'll find that. Transistor, bipolar, NPN. And we'll go right here, and this goes into the base of the transistor, which I should be able to just draw like that. And it even shows you there the base, collector, emitter on the drawing. So that resistor comes into the base. Out of the emitter, we're shown going right to ground. So we'll put that in, right to ground. And out of the collector, we go to a lamp. So we'll draw that in. And then above the lamp, we're going into a 12 volt DC power supply. So add voltage source, single terminal. We'll attach that, edit that, make it 12 volts DC. So that might not look like what he has, but I'm pretty sure it's going to work the exact same way. And so the entire point of this here, he's looking at pulse width modulation. So as soon as we open up this here bulb, we click on the bulb, hit view and scope. Yours might look a little bit different. Depends on how you zoom it. You can kind of change it in the properties here. And you can adjust your zoom, kind of like that. And what you'll find, so right now you see, so it started out here and it dropped down. And I'm not sure what just happened. Let's see. Why is it doing that now? Oh, I see what I've missed. Okay. I missed a wire. It looks like on the drawing. Over here where I jumpered the trigger and the threshold, pin 5 and 2, that there also has to go between the 10k ohm resistor and the capacitor. So we're going to add a wire going this way, like that. And we'll hit run again. There we go. Now we have some pulsing going on down here. And this is where everyone's might look a little bit differently based on the zoom you have in your properties. You can really adjust this. I'm pretty sure, looking at Henry's drawing, he had this kind of like It wasn't going that fast probably, but you know, he was zoomed way in like that. And what you can do is you can slow it right down, right? So the sim speed, slow it right down, and you can zoom in and see the pulses. So just looking at it here now, you know, we're at 0 volts. It gets to this point and it pulses. And it's reading negative 1.8 on the scope. I'm not sure why it's saying that. But up here at the lamp, if you hover over it, down in this corner here, you'll see it going between 1.831 volts, and then it'll dip down to 1.89 PV. I think it's like picovolts. It's a really small number, almost 0. So what we have now is a bunch of pulses with different widths. And what the lab is supposed to show you is the pulse width changing based on the resistance of this pot. So right now I have the pot turned way down. If I crank that resistance up, as these new pulses come into view, you can see already that first pulse is much wider low, and then it dips, and then back right up again now to 0. And so now it was going, you know, on, off, on, off, on, off. Now it's going off, on, off, on, off, on, off, on, off. So just by playing with that resistance in the pot, you can change how fast that pulse is, or how wide that pulse is, which is going to change your overall average voltage. So say you actually had that light, by changing the resistance, it would probably cause a dimming effect, depending on how you had that set. So say it was on, say back in this case over here, say I do this, I turn the resistance way down. Now it's on for a very long period of time. The on pulse is very very long. So it's a very wide on pulse. It'll probably stay on forever actually. So I give it some resistance. I have it at 0 now. There we go. So now the on is a very long pulse, and the off is very short. And then followed by another very wide, long on pulse, and then a very short off pulse. So that light there is probably on very, very, very brightly. If you turn the pot all the way up, all of a sudden, that light is probably going to start to dim, because now it's off for a long time, on for a short time, off for a long time, on for a short time, off for a long time, on for a short time. So all he's showing here is that with the timer and the transistor and the pot, you can change the width of the pulse, and if you had a real light here, you'd see that light go bright or dim, depending on how wide those pulses are, if that makes any sense at all. Hopefully that helps you figure it out. If not, we can look at it some more. Whatever works for you.